Okay, so the whole basis for this next unit, which is going to last all of 4 classes, right? That's all we need to cover this stuff. 4 classes, okay? Really, I could do it in 1, but, you know.
Do it.
You're going to get most everything you need to know today. So this is the basis for the whole thing, right? So if you're missing today, then you're not here, and hopefully you're watching this, because otherwise you're missing the basis for the whole thing, and it's just not going to go well for the next few days. So let's start with a circle, or something that resembles a circle. What do you know about a circle?
There's a dot in the middle.
There's a dot in the middle. What's that called?
The center.
The center, yeah. Nucleus. You're overselling it if you're saying nucleus. Center. What else do you know about a circle?
Radius.
Has a radius. Okay. Where is the radius?
Middle to the edge.
Okay. So a circle has a radius. What else do you know about a circle?
Diameter.
Okay, diameter. I'm not going to draw that on there, but that would just be either, you know, just any line that goes through the center and joins 2 edges, right? So, or another radius just to the left of that one, so that the 2 radii are in a straight line. What else do you know?
2 pi something.
2 pi something. What else? Okay, I'm going to throw out a word. Degrees.
Whoa.
What do you know?
360.
360 degrees in a circle.
Yeah.
Okay, fine. So, what's a degree? What's 1 degree?
1 inch.
1 inch. So this is 1 degree. Anybody agree? This is 1 degree.
It's 1 tick on your protractor.
1 tick on your protractor. How many of them are there in a circle?
360.
So what's 1 degree?
1/360th.
1 degree
circle.
is 1/360th of the way around a circle, right? So if you're going to draw that, you draw it like this, and this is not to scale because that's way more than 1 degree, but I have to leave something so you can, you know, resolve that there's actually a space in there. So that's 1 degree, right? Which is 1/360th of the way around a circle. All right, why 360 degrees in a circle? Seriously, why 360? Why not 100? Why not 400? Why not 1,000? That's the way it is. That's pretty much the right answer, right? It's the way it is. At some point, as a species, we decided that there will be 360 degrees in the circle, and so there it is. There's 360 degrees in the circle. Why? Probably the Babylonians. I blame them. Because they were big into the number 360. It's also divisible by a lot of numbers, right? 2, 3, 4, 5, 6.
What was 100?
10. Yeah, 100 is not divisible by 2. It's close to the number of days in a year. So if you think about, if you knew that it took 365 days for the Earth to go around the Sun, unless you were not heliocentric, then the Sun to go around the Earth, or, you know, if you were solar, or what's terracentric, I guess, or something, I don't know. Yeah, if you were wrong. So that could be another reason, right? But it's lost. It's like why we have the QWERTY keyboard, right? Actually, we know why we have the QWERTY keyboard. Why do we have the QWERTY keyboard? The QWERTY, I just say QWERTY, because that's what's in the top row there. Why do we have the QWERTY keyboard?
Because QWERTY is the most used letter.
Sure, Q. That's in almost every word in the English language, Q. Actually, what's the most common letter in the English language? Used in words.
E.
E. And where's E, right? So Q, W, E. I have to take this finger, the middle finger, and I have to reach it up, right? Like, where should E be? Probably underneath your most dominant finger, right? Like your right index finger or something, right? Because you're going to use it the most. But why? No, you got to sit there and do this to get to E. Why would you have to do that? Okay, here's why. It's the most inefficient way of typing. That's why. It's to slow you down. And the reason is, ever see the old typewriters? They got little letters on the end of arms. So you push the key and this little arm swings up, right? And it's got a letter on the end of it, and that hits a ribbon, it pushes it into the paper and leaves the impression, and there's the letter, right? So you got all these little arms that are popping up. So if you ever watch like an old movie or something, or see an old typewriter, these little arms are flying. Well, what's the problem? If you type too fast, the arms fly up at the same time and they jam. So we need to slow you down. If we slow you down, there's less chance of them jamming. So if we make a common letter like E or I, right? I, you gotta reach with this finger, right? Or U, or vowels A, that's sitting under the little finger. If we make the common letters hard to reach, then you're gonna type slower, okay? And then IBM went and invented the Selectric, which has a little type ball. So as you type, then there's no more arm to jam, right? So you could type a lot faster. And there's better keyboards out. There's one called the Dvorak keyboard, which is designed that you can type faster. Problem is, the QWERTY keyboard is out everywhere, right? So that's what we use, right? And it's inefficient. You could type a lot faster on a different keyboard. Why 360 degrees? At some point, somebody decided, hey, 360 degrees. And we all said, yeah, okay. That's where we are today. Well, okay, only we're not there, right? Because we are not going to use degrees on our calculator past today. Okay, we'll do a little bit today with calculator and degrees. So there's another system for doing angles, right? What is it, you know? What's it called? Not degrees. What mode does your calculator go into? Radians. What's a radian? I don't know, it's like some other mode your calculator goes in, then you got to switch it to degrees if you're in Math 10 or Math 20, right? Because we use degrees there. Here, we use only radians. And here's what a radian is. So radian, what's the word radian sound like?
Radius.
Radius. So here's a radius, right? This is R. R is the radius of the circle. Now, what we do to make a radian is we take the radius, right? And each circle has a fixed length radius, right? Agree with that? So what we do is we take like a piece of string and measure the radius. And then we take that radius and we lay it off along the circle, right? So I take this length, put on a piece of string, and I bend it along the circle so that I have this length here also being R. Then I draw that, R, and this angle here is what? A radian, 1 radian. So, think about it, right? So, you know, the aliens came to Earth and we got around to talking about circles, which is a universal concept, right? I mean, circles should exist everywhere in the universe. And we said, yeah, circle's got 360 degrees. And they go, what? What's a degree? It's 1/360th of the way around a circle. Are you nuts? Like, how'd you come up with that? Just pick some random number and say, hey. Whereas here, think about it. A radian is described in terms of a part of the circle, right? Everything you've got to get 1 radian is right there. You don't have to take some special protractor thing that has a degree on it and use it to measure. You don't have to split a circle into 360 parts and say one of these is a degree. All you do is you take the length of the radius, you lay it off along the circle itself, and then you say, that's 1 radian. Right? So now everybody should understand that that too should be a universal concept, right? So I would do, hey, we take this length, we lay it off here, we call that a radian. They'd say we call it something else, but the idea is the same. Okay, how many of these radian things are there to get around the circle?
360.
No, there's 360 degrees. Okay, what's the formula for the circumference of a circle? What's the formula for the circumference of a circle? Distance around. 2 pi r. He said, with conviction. Even though his voice went up at the end, indicating 2 pi r.
Voice crack.
Yeah, that's right. It's grade 7. Pi r? 2 pi r. So there are 2 pi. What's this thing? Radius. What's this thing? It's a radius, right? That's still the radius, right? How many of them are there around there?
4.
There's 2 pi of them, right? There are 2 pi radiuses, if that's the pearl, right? That's a radius, that's a radius. How many of them are? Well, the circumference is 2 pi r, that's r. Okay. So what's 2 pi about what?
6 point.
What's pi? 3.14. You don't need to go any further.
Wait, what is that sign?
So 6.28 radiuses. So if you take a radius, right, measure it out on a piece of string, put it here, measure this off, go to here, and keep going around, you're going to find there are going to be 6, and then about 0.28 of them, right? Exactly, there will be 2 pi of them, right? But pi is 3.14, etc. Okay. Since there's about 6 of them, then 1 radian is going to be around how many degrees? Yeah, it's about 60, right? It's actually a little bit less. It's like 57.8 or something, right? So radian's like around 60 degrees. It's really, I think, 57.8 degrees or something. But it's about 60 degrees. You can say about 60.
What is the square root equal sign?
Approximately.
Okay.
It's not equal, it's about equal. You may also see it written as an equals sign with a dot over top, or 1 flat line and 1 wavy line. Just mean it's about. All right, that's all you need to know about radians. Okay, you can skip 8.1 in the book. Well, actually, sorry, we're gonna do one more thing with radians and that. But 8.1 in the book is all about converting. You don't have to convert. So if there are 2 pi radians to go around the circle, which is about 6.28 radians, or how many degrees? How many degrees around the circle? 360. So 2 pi radians is 360 degrees, right? That's an is, like for sure, right? There's no doubt it is 2 pi. So what's pi radians? So pi radians, okay, which is about 3.14 radians. How many degrees will that be? 180, right? It's going to be halfway around. Okay, so if 2 pi is all the way around, pi is halfway around, and that's 180 degrees. And we'll do one last thing. So we'll take pi divided by 2 radians, which is about 1.57 radians, and is exactly how many degrees? 90 degrees, right? So full circle, semicircle, it's a quarter of a circle, right? 90 degrees. Right angle, right angle. Okay, that's all you need to know about radians. All right, so what's this unit about? It's about sinusoidal functions. Sinusoidal function is y equals sine x. Oh wait, I was going to graph it on the calculator. Ah, heck, I'm not going to graph it on the calculator. So you can graph this on your calculator. Do you want me to graph it on the calculator?
Yeah. Please do not bring up the calculator.
We'll graph it on the calculator. So, okay, so I got to change the mode to degrees, which is what you're never going to do with your calculator, except for now. Okay, so you change it to degrees now. Otherwise, here's the nice thing, right? You're going to walk into the diploma exam, you're going to sit down, somebody's going to clear your calculator. You do not have to go into mode and adjust it at all, right? Unless you want to change like the number of decimal places you're seeing so you get the right rounding or something, but you don't have to change from radians to degrees unless you want to get questions wrong. So you're going to leave it in radians, but we're going to do degrees. Okay, window. So we're going to start at 0. We're going to go to 720 degrees. We'll do it by 90s. That'll be our scale. And we'll go from negative 1.5 to positive 1.5 by, let's go by 0.5. And we're going to graph y equals sine x. Close that off. Okay, so this is what we're graphing. y1, y equals sine x. Here's the window we're going to use.
Wait, can you pause the window?
I can pause it, but I can just leave it up there running.
I meant like.
So 0 to 720 by 90. And negative 1. I think I know what you meant. Negative 1.5 to positive 1.5 by 0.5.
I know what you
Okay, let me know when I can.
Okay, you're good.
All right, and it's going to graph. So I watch it graph. It's kind of neat, right? Watch it.
Wow.
You know, it's got its ups and downs, but that's the way it works. So a sinusoidal function is called a periodic function because you notice it repeated, right? So it went up, it went down, then it went up, then it went down, then it went up, and it would keep going like that, okay? So it's important that we know what is a periodic function, right? It's one that repeats with something called a period, which we'll get into in a minute. So this is 90, 180, 270, 360, 450, 540, 630, and 720. Right, so that's all the degrees, right? Because we use 90 as the scale, right? So 90, 180, etc. All right, and let's look at it here because it's a lot easier to see. We can see, oh, look, so the point 90, comma 1 is on this graph, as is the point 0, 0. As is the point 180, 0, and 270 and negative 1, and 360. And
It's just going up by 9.
just it's going up by 9. Yeah, but what's happening is really, the way we can think about it is, it's off the board anyways. The way we can think about it is, it's happening in 4 parts, right? So there's a part of the graph where it starts at 0, 0, right? So it's starting. Now, in relation to the rest of the graph, where is this line? In the center, right? We're going to call that the middle. So we're going to call it the midline. Or, what's that thing running down the middle of the road so you can never make a left-hand turn when you want to?
Dotted line.
Yeah, in the road.
Oh.
The what? Median. Right. So we're going to call this the median. Because it's in the middle, right? Or the midline. So maybe referred to, or the middle. Or the center. Nah, I don't want to call it center. Wow. Now it just, everything moved. Whoa. Now it disappeared. All right, hang on. All right, it's all back. So the median or the midline or the center, I'm just going to move this so that the midline's back in the middle. That's in the middle. Okay, so that's an important part of this sinusoidal function, right? It has a median, a middle, or a midline. A sinusoidal function has an amplitude. Who's heard amplitude before? All right, so anybody's done physics, you've done stuff. What's the amplitude? Like, where is it? What is it? So I say the amplitude is either how much or how do I figure it out? So the amplitude is from the middle to the highest part. This is amplitude. Or from the middle to the lowest part. This is amplitude. Okay, so 2 things we've defined so far, right? The median or the midline. You're generally going to refer to it with one of those 2, median or midline, and the amplitude, median or midline, and amplitude. Okay, sinusoidal function is called a periodic function. So it repeats with a period. So the period is split. I like to just say it's split into 4 parts. Okay, here are the 4 parts. It starts in the middle, right? There's 0, 0. So 0, 0 is in the middle, and this graph is going up. Starts in the middle, goes up. It reaches a maximum. So this is the maximum. Maximum. From the maximum, it falls back to the median or the midline. From the midline, it goes down to, what are we going to call this?
Minimum.
Right, so if that's the maximum, this is the minimum. And from the midline, it goes back to the middle, and where is it? It's back where it started, right? Where did we start? At the middle, going up. We go up to the top, we come down. We're at the middle, but now we're going down. So we haven't gone through everything yet. We have to go down to the bottom and come back up. And now we're at the middle going up. So this is one period, or one cycle. So the graph has gone through a full cycle, right? It started at the middle, went to the maximum, back to the middle, down to the minimum, back to the middle. That's one cycle or one period. What's the period of this function? How long did it take? So now if we're looking on the x-axis, how long does it take to go from here back to here? 360 degrees. Full circle, 360 degrees. Okay, so one period or one cycle is 360 degrees. Okay, now all this is in your book. It's on page 492, right? It's all defined. All of this amplitude, period, etc., etc. All right, what I'm going to do now is switch this from degrees, which we're not going to use, to radians, which we are going to use. So I'm going to go here to set. I'm going to change this to radians. Now, okay, remember, there's 360 degrees in a circle, but how many radians are there? 2 pi. It's only like 6 and a bit radians, right? So if I say you're going from 0 to 720, that's like 120 cycles. So I need to adjust this, right? I got to say, hey, you don't want to go from 0. So I'm going to take this from, I just want to go a little bit below 0. So a little bit below 0, we'll go like negative pi divided by 6. And I'm going to go to 2 pi, actually, you know, I'm going to go to like 13 pi divided by 6. Yeah, we'll do that. And I'm going to leave the y values the same. They're not going to matter. All right. Okay, so we got 0, 0. Now notice these guys are still, now instead of 90 degrees, it's pi over 2. But we know that, right? 90 degrees is pi over 2 radians, right? Pi over 2 radians, which is about 1.57 radians, right? If you just take pi and divide it by 2, you get about that, is 90 degrees. There's pi radians, right? 180 degrees, right? So we went up here. That's 90 degrees, 180, 270, 360. 360 degrees was one cycle or one period. All right, so really, you know what? I should take that up to 2 cycles. So instead of 13 pi, let's go to 4, 4, 12, 24, 25. Let's go like 25 pi divided by 6. Okay, and then things should match up nicely with what we have. Okay, so here's one period, right? So it's still pointing about in the same place. It was extended out a little bit, but based on the scale. So it's 2 pi radians. 2 pi radians. One period or one cycle is 2 pi radians. If you split that into 4 parts, so I'm splitting 2 into 4 parts, which is going to give me 4 halves, right? So you take 2 pi divided by 4, you're going to get pi over 2. So stuff is happening every pi over 2. From 0 to pi over 2, we're climbing up to the maximum. From pi over 2 to 2 pi over 2, which we would just call pi, right? 2 over 2 is 1. We're back to the middle. From 2 pi over 2 to 3 pi over 2, we go down to the minimum, which is sitting at negative 1. And from 3 pi over 2 to 4 pi over 2, 4 over 2 is just 2, so we call that 2 pi. Right? So we've got a half pi, full pi, 1.5 pi, or 3 halves pi, and then 2 pi. Amplitude, still the same, right? The amplitude is 1. Doesn't matter if we're measuring in degrees or radians. All that affects is the x-axis, right? Doesn't affect the y-axis. So the y-axis deals with the midline. Where's the midline? Did it move? It's still under there, right? I sketched it in. The midline is still there. It's at 0. Okay. What's next? So next. Oh, x-intercept. Where do you cross the x-axis, right? So it's 0 at pi, at 2 pi, at 3 pi, at 4 pi, if we could see it. It's not quite there. It's just, well, that's 12 point. Actually, I could change that. Hang on. Let's change the scale. So the step there, instead of 90, right? I don't want 90. I want pi divided by 2. Okay, so 0, pi over 2, pi. So where do we intercept the x-axis? 0, pi, 2 pi, 3 pi, and 4 pi. Okay, that's where we intersect. Those are our x-intercepts. Where do we intercept the y-axis? At 0, right? So it starts at 0. Okay, here's what we're going to do now. We're going to clean off any of the writing. Wow, that's kind of slow. All right, so I can leave those guys on there. I'm going to adjust the scale. Oops. Go back here. I'm going to adjust the scale a bit. And what I'm going to do is take the y-axis and go from like -5 to 5. Okay, so there we go. And I'm going to adjust the equation. So here is the equation that you're going to get. Okay, so you're going to be given, I think it's on your formula sheet, but let's see, I got a formula sheet here. So formula sheet says sinusoidal functions. It comes out y is equal to a, so there's an a in front, sine, and then there's a bracket bx plus c, and then on the end there's a plus d. So that's the formula you're going to get on the formula sheet, right? It's going to say sinusoidal, puts down here. It says sinusoidal function says y equals a sine bracket bx plus c close bracket plus d. Now, in decimals, I can make sliders of those, right? You've seen it. We did that with other stuff. So I'm just going to say I want sliders for all. Everybody should have sliders. And I'm just going to move some stuff. I'm going to set c to 0, and I'm going to set d to 0. Right? Okay, so this is our basic sine function, right? So we've looked at it. Let's just go through it one more time. Basic sine function. It's got a midline at y equals 0, right? This is the midline. The equation of this line is y equals 0. Starts at 0, 0, climbs up at pi over 2 units, or 1/4 of the cycle, right? Remember, cycle's 4 parts. What are your 4 parts? From the middle to the maximum, from the maximum back to the middle, from the middle to the minimum, or from the middle back, or sorry, the minimum back to the middle. Or start at a maximum. Where would you end? You'll end at the next maximum. So max to middle, middle to min, min to middle, middle to max. Or start at the middle but going down this time, right? So here's 1/4, 2/4, 3/4, 4/4. Or start at the middle but going, we already started at the middle going up. Okay, so you got 4 parts. You can start anywhere you want. Just remember, each part takes 1/4 of the period, and the period of this is 2 pi. Right? You've got a max value of 1, you got a minimum value of -1, you've got the amplitude, which is from the middle. So that's your amplitude, right? So it's the distance from the middle to the max, or from the middle to the min, or it's half the distance from the maximum to the minimum. Okay, so that's another way to look at the amplitude, right? It's half the distance from the maximum to the minimum. All right, so what we're going to do is we're going to play with each of A, B, C, D and see what's the effect on the graph, right? So I'm going to start D, and I'm just going to let it play out here. And what we'll do, though, is we'll change this so it goes from -5 to 5. Hang on. Clear. -5, 5, yeah, whatever. Okay, so press play. All right, what's it doing? Wait, is it shape changing at all?
No.
No. So its shape isn't changing, right? It's not getting any wider or narrower, right? It's like horizontal. It's not getting wider or narrower. It's not getting higher. It's not getting bigger, right? It's not getting larger in a vertical sense, right? So its shape is exactly the same. So all it's doing is moving up or down. So the D value in this equation changes what? The height, but what's changing? So where did we say here? Let me just stop it. So the midline was at 0. Where's the middle now? 0.5. Let me just change it here to a nicer number. So if I make the D value 3, where's the middle? It's at 3. Right? There's the middle, right? Because there's the top. So what's this distance called? Amplitude. And the amplitude is how much? How far is it from 3 to 4? 1, right? So the basic sine function has an amplitude of 1. Did we change the amplitude? No, we're simply changing the midline, right? If you change the midline, what's the effect on the graph? It moves it up or down. Okay, so let's go back here. And we're going to say, here's what we're looking at, right? We're looking at y is equal to a sine bx plus c plus d. And we can say that d is the midline or median, right? You can call it the midline, you can call it the median. Don't call it the center. That's for circles, right? It doesn't have a center. It's got a middle or a midline. What happened to the graph when we changed D? The graph is shifted up or down D units. Okay, so if I change D, I move the graph up or down. How far up or down? However many units D is, right? D is positive 3, it moves up 3. If D is negative 3, it moves down 3. Well, it changes all of the y values, yeah. Because the y value that was 0, 0 is now 0, negative 3. The y value that was at positive 1 has moved down 3. So 1 minus 3 is negative 2. The y value that was at negative 1 has moved down 3, so it's at negative 4. So yeah, it changes all the y values. How does it change them? It subtracts 3 from each of them. Okay, I'm going to put D back to 0, right? Because we should only change one thing at a time. So we changed D. We saw the effect of it. Okay, so going back. So here's just our regular sine function. Y is equal to 1 sine 1x. Right? What did we graph first? It was just y equals sine x, right? So that's 1 sine 1x. So next thing we're going to change is A. And I just want to change this. So we'll go again, we'll just take our A's from -5 to 5. And we'll click off of that. So press play. All right, what's changing?
The height of the amplitude.
The height, yeah. So let's just call it the amplitude.
Okay.
So the amplitude is changing, right? So is the midline moving? No, it's still at 0, right? Because what's the midline? Which variable is the midline? D, right? And what's D? 0 or negative 0. That shouldn't make any difference. It's just, I didn't delete the negative. So D is 0, right? It hasn't changed. Is the period changing? Mm-mm. So what's the only thing that's changing? Amplitude. So what's A? A is for? A is for amplitude. D is for midline or middle. You can make a case for that, right? Because there actually is a D in the middle of midline, or in the middle of mid, not quite, but it's close. So D is the midline, right? There's a D there, or the median, right? Where the D isn't quite in the middle. But A is for amplitude, right? Years ago, A was for apple. Right? Learning how to read, it was like A, apple. B, ball. Okay, so A is for amplitude, right? The amplitude is defined as the distance from the middle, or the midline, to the maximum. Okay, so distance from the midline to the max, or the midline to the min. Okay, and as we get into it, we'll get a formula for amplitude, right? We'll come up with a formula, which is not on the formula sheet. Okay, so if you want to remember the formula for amplitude, you'll have to remember the formula for amplitude, right? You're not going to get it on your formula sheet. Really? It's chosen now to die. Oh no, that's Firefox. I didn't want that. Hang on. How do I stop that? Oh, let's just go here. All right. So A is the amplitude, right? So there's 0, 0. Here it's showing the minimum value is negative 1.25. Maximum value is positive 1.25. Here's the middle, or the median, or the midline. So a lot of times, here's my advice, when you get a sinusoidal graph, first thing you should do is stick a ruler on top of it and draw in the midline. Right? If you do that, you're going to know the value for D, right? As soon as you draw that line across, you just say, all right, where's it hitting the axis? Oh, it's hitting at 2. So the midline is 2. That means that the equation, the midline, is y equals 2. Right? That would be the midline. Here it's just y equals 0. All right, let's go back, change that to an actual 0. All right, we're going to change A back to 1. And now we're going to let B change. So let's do that from negative 5 to 5. Because we can. Okay, so what I want to know is what's changing. So it shouldn't be the midline, right? That's B changes midline. A changes amplitude. What's changing? Period.
Oh, jeez.
Yeah, actually, what happens when it goes negative is you actually get a reflection, which we don't have to deal with, right? So you're never going to have to worry about a negative value for A or a negative value for B. D, that can be negative because you're just moving it down. Okay. So what does B do? Changes the period. Okay, so I'm just going to pause, or not. I'm going to pause. I'm going to set B equal to, so for a normal function, right? Remember, this is our normal function, right? Period is 2 pi. 4 parts. So for a normal function, B is equal to 1. I'm going to change it to 3. All right. What's the, actually, no, I'm going to change it to 2. 2. What's the period? So start at 0, 0, just go through the 4 parts. How long does it take to go through all 4 parts? Up, back down, bottom, back up. It's on there, it's listed, it's labeled. So starting at 0, 0, go up to the top, back to the middle, down to the bottom, back to the middle. How long does it take to do that? x value. What's the x value? The top. How long does that take?
Here, pi?
Pi.
I don't think I see it.
I'll fix your eye if you can't see that. Seriously.
Reflection.
Yeah.
Reflection. I can see it from here. You have better eyes than I do.
All right, fine. Okay, here, we'll do this. All right, how long does it take to go through one complete cycle? Pi. We can see that now, right? You can see that, pi. No excuse. All right, so here's the deal. B. Not the period. See, D is the midline, right? If D is 3, the midline is now at 3. If D is -2, the midline is at -2. If A changes to 5, the amplitude is 5. B changes the period, but it is not the period. What's the period? The period is, normal period is 2 pi. Sure. Is there one? Yeah? Yeah? Sure. Okay. Here's the formula you're going to get on your formula sheet.
Wait, did I give you that stuff? I need to change it to easily distracted.
Did you not put that?
Yeah, I should have. I was trying to be nice. Changes, so the period is 2 pi divided by b. So b is not the period, but you can work out the period if you know b, right? So if you see the equation, which is in the form y equals a sine bx plus c plus d, and you say b is 2, and the period is going to be 2 pi divided by 2. What's 2 pi divided by 2? Pi. Right? So we go back here. B is 2. The period is 2 pi divided by 2, or pi. So what if I change B to 4? Then what would the period be? Yeah, 2 pi divided by 4, or pi divided by 2, half pi. Okay, so here, half pi, right? One period, half pi. Here's another thing that B does. B is the number of cycles in 2 pi. So if I go here and I say, look, here's 2 pi, and here's 0. And how many cycles do I have, right? So 1, 2, 3, 4. Well, that's what B is, right? It's telling me the number of cycles in 2 pi. Right? How big is each of those cycles? Well, we know that one cycle is 2 pi, so it's 2 pi divided by 4, or pi over 2. So what if I change B to 1/2? Then what would the new period be? What's 2 divided by 1/2? How many halves are there in 2?
4.
4. So if I change that to 0.5, then the period should be 4 pi, right? Well, here it is. 4 pi. And if you're looking at this on video, you can't see it, but the 4 pi is just outside the window there. So period is 4 pi. Okay, so we've got this going on, right? B, so D is the midline, right? If D is 5, the midline is 5. If A is 2, the amplitude is 2. If B is 2, the period is not 2. It's 2 pi divided by 2, which is pi. All right, what's left? We got A, we got D, we got A, we got B, C. So what does C do? So let's change this back to 1. So always go back to our starting point, right? 1 sine 1x plus 0 plus 0. Okay? So I'm going to change C. We'll let it, I can go from -10 to 10. So you got to say, okay, what is C doing? Nothing at the moment. All right. So what's moving? So the whole graph's moving, right? So is its shape changing? Is it getting taller or smaller? Is its period changing? Is it getting wider or narrower? Yeah, is its midline changing, right? So no, I mean, what changes the midline? D. So D is still 0. What changes the amplitude? A. A is 1. What changes the period? B. B is still 1. So period is still 2 pi. So C is a horizontal. It's a left or right. Shifting it to the left or to the right. It's got a special name. It's called a phase shift. Okay, it's going to reset that to 0. So C is the phase shift. C, phase shift. And what it does is translates the graph horizontally, graph horizontally, okay, which is left or right. Left or right. Okay, D is shifted up or down, right? So that's vertical. So D we might call a vertical translation, right? And you guys do 30-1 before you came to your senses? No? Good. You came to your senses early? So if you'd done 30-1, you would have talked about a vertical shift, right? Or vertical translation. So that's what D is, vertical shift or vertical translation. Okay? And if you'd done 30-1, you would have talked about horizontal translation, right? And that's what C is, it's a phase shift. And if you're going to do 30-1 at some point, you're going to revisit the sinusoidal function and look at it from a point of view of the other transformations that you did in 30, or that you do in 30-1. Okay? So we're interested in these 4 things, right? D, the midline or the median. A is the amplitude, which is the distance from the middle to the maximum or from the middle to the minimum. Remember, it's the middle, so it's the same distance whether you're going up to the top or down to the bottom, right? Doesn't change. B will change the period. Okay, and C is a phase shift, which changes the horizontal placement. Now, one other thing we should look at, we're going to look at this function, y equals cos. So you've heard of cosine, right? Of course we have. You are not responsible for the cosine. It's like all over the book, right? The book has cosine all over the place. That's why the book sucks in this unit. Like, seriously, you know, I mean, there's some decent questions in there that you could certainly do, but there's a whole lot of garbage in there. So, y equals cos x. So how does that compare to the sine function? Say, well, okay, it's got a maximum of 1 and a minimum, so it's got the same max and min. How long does it take to complete one cycle? So it starts there, so there's pi. So what's its period? 2 pi, right? And so in this case, we can measure the period from the max, because it starts at the top, right? So it goes maximum to middle, middle to minimum, minimum to middle, and then back to the max. Okay, we'll just take this off projector, we'll make it a little thinner. Okay, so cosine has a period of 2 pi, same period. Cosine has a midline of, where's the middle? 0, right? Same midline. Cosine has an a value, right? If you think of this as being written, right? I mean, I could write it the same. Let's just play with this a bit. So I could go 1, wow. Let's change that right here. 1 cos bracket 1x plus 0. I should get rid of that x. Plus 0. Okay, there's cosine function written in the same form, right? A cos bx plus c plus d. So we can say, all right, d is 0, the same. C is 0, the same. B is 1, that's the same. A is 1, that's the same. We have the same amplitude, the same midline, the same periods. What's the only difference between these 2 functions? It's shifted, right? So it's a phase shift. If I took this guy and shifted it over, right? I take this maximum and just shift it over this way, then it would lie right on top of the sine function, right? So I can do that because I kind of know how. So I'm going to do that to this. I'm just going to give it a phase shift. I'm going to say minus pi divided by 2. And now where's the black line? Okay, so I turned it off. Turn it back on. The only difference between sine and cosine is a phase shift, right? There's the sine function, and here's a shifted cosine function. Okay, sine function, shifted cosine. Put this back to 0. Or not. Just change that to 0. And we're back to the cosine function, right? So the only difference between sine and cosine is phase shift. You are not responsible for cosine. Everything you do will be in terms of sinusoidal. There will be a little bit of cosine stuff in the assignment today, which is 8.2, numbers 1 to 6. Okay, so that's what you want to be looking at for the rest of the period, next 20 minutes. And so it won't take long to do. It's fairly straightforward stuff. So it's just going to ask you about characteristics, right? There'll be a little bit of cosine stuff, and there may be some degrees stuff. So you may today have to set your calculator to degrees just to play with it a bit and just get used to the sine and the cosine. Okay? So that's almost all you need to know about sinusoidal, right? But tomorrow we're going to go into a little bit more detail on, hey, if you give me the equation, how do I know what the characteristics are? And then the other lesson is, hey, if you give me the graph, how do I know what the values of A, B, C, and D are from a graph? So you give me A, B, C, D, what does that do to the graph? You give me a graph, how do I know what the values A, B, C, and D are? And then the last thing is running a sine regression. So we take some data which is cyclical, and we plug it in, run a sine regression on it, and then make some conclusions about it, right? Now if you want to think about what kind of data is cyclical, think about temperatures. Right? So we're at spring now, so temperatures are about in the middle of where they are, right? And then they get really cold. So December, that's really cold. It warms up to spring. Then it keeps warming up until we hit summer. Then it starts to cool down. And then we hit fall or autumn. And then we go down to winter, and it goes down again, and then it climbs back up again, and so on. Think about the number of hours of daylight we have. Take the hours of daylight, we're starting to get more, right? It's starting to be light outside when you get up. It's light outside, you know, if you think back to December, come to school in the dark, you go home in the dark, right? Think about July, pretty much whenever you're, you know, getting up, it's light out, because it starts to get light out at like 4 or 5 in the morning, and it's light out fairly late. You can sit outside and read a book at 10 o'clock at night, right? So hours of daylight, something that's cyclical, right? Anything in nature, a lot of things in nature follow this pattern, right? So we're going to learn, can we model hours of daylight with this idea? Can we model temperatures with this idea? And that's where we're going with this whole thing.